So now the next one we are going to look at is a little bit down these chapters. The MIPS R2000 assembly language, and it has addressing modes, right? We already know different addressing assembly language which SPIM supports. Okay, so very similar to the list of we define here. All these like 5 type of addressing modes are in fact supported here. So we have the register, okay, register mode. We have the immediate. Then we have the immediate register, so register relative addressing. Okay, then we can do as a label address of the label directly. Then we can do have some mode in the assembly coding itself. This is nothing to do with the processor addressing mode. Okay, so processor only support these 5 different addressing mode. Okay, now here from the program perspective, we can use a label to address like jump or somewhere, go to somewhere. Then we can also do some label, and with respect to that label go up and forth. So this is more like supported by the assembler through the sudo instruction. Okay, and also this one like content of a register plus address of the label plus minus immediate, so jump from that location. So it is a kind of one more level of abstraction, I'd say, from this label, using the label, immediate, and also combine them with the register content. So all these things are basically supported by the assembly language and the assembler itself through the sudo instruction. Okay, through the sudo instruction. Mainly it is the native form of the addressing modes is the register mode, immediate mode, and immediate register relative mode. Okay, and if you think of like register relative mode is like PC relative addressing is practically this as a fall under number 2, a special case of that where the register being PC. Okay, so other thing from here we want to learn about. Okay, if you read these, like it talks something about the aligned data. Don't worry about it for time being. We'll be learning about the data alignment later in lecture, not like today's lecture or tomorrow's like next day's lecture, but it is probably scheduled after that lecture, is after 2 lectures, so don't worry about that. Next we are going to see what is this assembler syntax are. We already kind of familiar with the assembler syntax. We know the dot data is starting off a data statement, and then we can do a label item or something like that. Dot word is basically we are defining a word which is 32-bit data. So this one will be stored as a 32-bit binary value of 1, which is like 31 bit of 0 and then another 1, right? We have seen this dot text, which is start of on program assembly program, and then we have seen this global main. So this is declaring my main is the global level, and then main we are defining with some load word. And we already know, we have seen in the memory lecture that what is a load word. So this guy is basically trying to load the content of this address, which is by a name item. So it will be loading number 1, which is stored. This item is storing word, now a value of 1. It will be that value will be loaded into the T0. Okay. So when we write numbers and in the assembly program, one thing to note is this: numbers are base 10 by default, unless you do something like 0 cross, this is hex, okay, like 0 cross 10. So this means the hex 10, not the decimal 10. But if I write a 10, it's by default for assembler it is a decimal number. Okay, so that is one point to note. Another point is that strings are enclosed within the double quote. Special character in the string followed the C convention. If you remember, I think the Java also has similar convention. So basically, you have seen, right, this, okay, string 1 dot ASCII Z is, this is a string, let's say something like that. Okay, so here any special character is kind of like /n is a new line, /t is a tab, and if we want to encode the quotation itself, a part of the string, so we do this. So this means equivalently the stored string is this. This is a open quote string close quote. Okay, and of course new line and padded with a null character, that's a string. All right, so this one is, please remember that convention. And then we have seen couple of directives already, like .text, .data. Here this section tells you more about different directives we have. Just skip the align, .align right now. We'll be learning more about the data alignment later. .ASCII and the string that we have seen a similar thing like ASCII Z, right, where it basically this string will be null terminate it. But if we just do a ASCII, then it will be just that string, like it won't be appended. It will not be appended with a null character, so string won't be terminated. So I usually prefer to use this one to define a string that is safe to use. Now byte is basically giving a byte location. We have already seen an example of the byte data storage. So it will be whatever number you are doing, it's in byte. So it's an 8-bit number, which means the values in this way we can only have like 0 to 256 like unsigned, and then minus 127 to 128 in the if signed, if we consider that. So that is the byte data values. And .data we have seen, and we have seen that this is marking, okay, whatever followed this section is and defining data to be stored in my global and static space, data space of the program. It can be an optional address. We haven't used that, and I will see it in later what is the usage of this one. But this is telling that I can, like, if I omit this, this is an optional. If I omit this, the data section that is data stored will be stored from the default location that the system allows you. But here we can override that and tell, okay, store the following data starting from this address. Okay, that we can do. Double number, so this is like a floating point definition of these numbers. We can do that. Extern, I believe we'll be learning more on the extern in details in the subsequent lectures. One of them, it's basically says that this is kind of an true global data, in the sense that if we have a multiple file, then we can access a global variable. In that case, not the global label, but global variable of one source code from another source code. If you are familiar with the C language, it is the extern variable that we use in the C. It is the same concept here. Okay, but don't worry, we'll discuss later more on this extern variable on that. Okay, Float is to define the float numbers. Global, we have seen like making a symbol, a global symbol. Half is a half word, which is 16-bit storage. So whatever number we are defining here would be stored as a 16-bit. Now .k data, k text, we won't be using much in this class. This is mainly to write the kernel code and kernel text for the system. Now no AT, this is a special one. So we have a register. Remember, we have a register which is used by the assembler, and user program should not use it because it is not guaranteed the value to be preserved in case we use a pseudo instruction and assembler uses that AT to as a temporary register for itself to manipulate certain value. Right, so this directive says that if we try to set the AT, okay, in our program deliberately, this one mode will give you a warning. Okay, it's complain about subsequent instruction. The first directive, like no AT, will give you the warning or error in the assembly level, right? When assembling your program, if it sees you are deliberately using an AT within your program without like using the pseudo code, it will give you a error. Okay. Oh, sorry, my bad. It's the opposite. If I put a no AT, which is I believe is the default setting in the assembler, then it will not complain. But if I set it like just for make sure that my program is not accidentally using this register, AT register, we want to set this out. And if it is set like set AT, then in that case, at any position we use $AT for any operation, it will give you an error or complaining on that. Okay. Now space n, this is like allocating n byte of space in the current segment, current data segment, and it is basically related to usage of this extern. Mainly we'll come back to that later and understand a little more on what is that. Then text, we have seen the text is again the beginning of the program. If we don't supply any address, by default it is the default power up location. The very first address start with that in translation process, but we can actually direct the assembler that hey, start putting the instruction from the beginning at this specified address. I don't put it on the power up address, but whatever address I am providing, start putting up your translated instruction from that address onward. And of course, we know that dot word is basically 32-bit quantities in the successive memory locations. Okay, so these are all about the directives, and remember, this doesn't have anything to do with the code generation except for this data layout. So this will all the data layout like a dot word and like a dot byte or dot ASCII, all those things put binary values into the memory in the subsequent locations. This is more like an directives for the assembler to stitch together different symbol and different variable defined across source file, and of course the kernel programming related stuff, and this is a little bit directive for whether to generate warning or not. So none of them actually creates any opcode or operation code in the program memory. So these are just pure directive that you're telling assembler to behave in one specific way.